Hi everyone, welcome back. In this video, we are going to start with our first type of statistical probability distribution, that is binomial distribution, guys. In our last couple of videos, we have learned that what is probability distribution, what are the different type of probability distributions like discrete probability distribution and continuous probability distribution, right? After that, we talked about different functions like probability mass function, cumulative density function, which we use to describe any discrete probability distribution. So these things we have covered in our last two videos, guys. I would suggest please go and watch them first if you have not already watched them, so that you can follow this particular video in a proper way, right? And I am going to recall all these concepts, guys, in this particular video to make you understand about the binomial distribution. And I can assure you one thing, guys, if you watch this video till the end, you will not forget binomial distribution throughout your life, guys, right? The examples I'm going to use, you will be able to relate that. Okay, so if you are new, I'm requesting you to subscribe the channel and hit the bell icon so that you do not miss out any of the video. As well as if you are liking the content, guys, because this kind of content takes a lot of time to create. So if you are liking the content, please like the video as well as share with your friends, colleagues, so that they also get benefited from this. And as I mentioned in the last video, guys, if I will have 500 plus subscribers, I'll definitely start with my live videos on YouTube so that you get benefit. You get all the doubt answered in the live video itself, right? So I'm waiting for that. Let's see. Help me, guys, with that, and I'll help you in your data science journey. So now let's move to the topic, guys. We will start with the binomial distribution. To understand binomial distribution or binomial random variable, guys, let's first see few statistical experiments which you can relate from the real world. So let's say you are sending mail to different customers. You are conducting a business where you are sending mail to different customers, and outcome here you are expecting whether customer will reply or not, right? So this is the experiment because it's a statistical experiment. Why? Because the outcome can be yes or no, right? Now, similarly, second example, let's say you are into a business of online courses where you have created one video campaign and customers are looking at your video. Now, the outcome of this experiment is after looking the video, whether they will buy the product or online course or not, right? Again, this is a statistical experiment. Output either yes or no, whether customer will buy or not. Now the third one, whether you will like this particular video or not. Again, it's a statistical experiment. Any video I upload, whether you will like it or not, that's a statistical experiment. Again, real world, guys, right? Now, flipping the coin, coming head or tail. There are two possible outcomes. Now, roll a dice, outcome as odd or even. Again, two possible outcomes, either odd or even, right? 1, 3, 5, 2, 4, and 6. Now, when you are swiping on Tinder, whether you will get your life partner or not, there will be probability, right? It will be very low. For few it will be very high, but definitely it's a statistical experiment. Why? Because the output is uncertain. Maybe you can get, in my network, definitely there are people who got their life partner from Tinder as well. Now, the next example, job application lead to hiring. You are applying the job. Every job you apply, whether you will get hired or not, right? It's a statistical experiment. Now, randomly picked person belongs to LGBT. This is again very interesting experiment, guys. These days, the numbers are increasing. I'm favoring that part. So definitely, you are picking a random person and that person belongs to LGBT, right? Again, it's a statistical experiment. Output of single trial can be yes or no, right? Now, I have given you a lot of these examples. What is common in all those examples, guys? There is one thing common. If you pause this video and understand all these examples, you will understand one thing, that the outcome of every trial in your statistical experiment, in all the cases, the outputs will be two. Either yes or no, in the form of, let's say, you will get your life partner or not. So here, yes and no, right? Coming head, that is your success, then success or failure, right? Head or tail, odd or even, whether you will get LGBT person or not, right? Yes or no. Customer will buy the product or not. So all of these statistical experiments, there are two outcomes and those can be labeled as success and failure, right? All of these statistical experiment has this thing common. Now, the second thing, there will be some probabilities to success. Let's say in our first example, success is getting a reply from the customer, right? So that is our success. Now there is a probability assigned to that particular success, and that will remain constant throughout all the customers you send mail to, right? So that's another condition. And the last one is all the trials are independent. You flip the coin, every time you flip the coin, all the trials are independent. They will not influence the probability of other trials, right? So now when you have all these conditions true, here the trial, individual trial will be called as Bernoulli trial, guys. And this is the base of your binomial distribution. So this is the most important part, Bernoulli trial. What is Bernoulli trial, guys? Trial, it's an event. Let's say flipping a coin once, that's a trial. Sending a mail to a particular person, that's a single trial. Let's say you send to 10 persons. So now you have 10 trials. Customer will buy the product. You are watching 50 customers and then you are looking at individual customer behavior. So every individual customer response is your trial outcome, right? Similarly, you swipe on Tinder, that is your single trial, right? So you have different trials in every statistical experiment. Your individual trial, we call that as Bernoulli trial if and only if these conditions are true. What are those conditions? The outcome of that trial should be two, either success or failure. That success and failure definitions are very subjective, guys. That depends on your experiment. So let's say when you are flipping a coin, you are getting head, that is your success. That will be your success definition, guys. For some people, it will be tail. Then for those people, the success definition will be tail, getting tail, right? So success and failure definitions change, but there will be two outcomes of every statistical trial you will get in Bernoulli trial. So now the second is probability of success. There will be probability of success, right? It will be low, high, depends on your experiment, but there will be probability of success, which will remain constant throughout all the trials, right? So let's say you flip the coin. First, you get head. Probability is 0.5. In the second trial, you flip the coin. Here also, the probability of coming head is 0.5. It should not get influenced by the first trial. So that is your probability of success remains same across all the trials. The third one is trials are independent. In no way they can impact the output of other trials, right? So these are the three conditions. If these are true, that is your Bernoulli trial. Now, all of these examples are actually for the binomial random variable, guys, right? Now, let's understand that. And all these examples you can relate, guys. All of these examples are practical. And I told you what are the common things in all these examples, right? Now, in your binomial statistical experiment, you will have fixed number of trials, right? Every trial will be Bernoulli trial. And there will be fixed number of trials, which we generally represent using small n. I'll come to the notations. Every trial will be Bernoulli trials, as I already mentioned. Now, what is binomial random variable, guys? So now binomial random variable defined as number of trials that result in a success. We call it as binomial random variable. And this binomial random variable will have a probability distribution. That probability distribution, we call it as binomial distribution, guys. So binomial random variable will have binomial probability distribution. I hope this is clear. Now, if let's try to understand using any of this example, all are same, guys. You will be able to relate. Let's say you have sent mail to 100 customers, right? So here you have fixed number of trials. How many trials are there? Number of trials are 100. Now, out of those 100 numbers of trials, your random variable is the number of success, right? Number of customers who will respond. Now that number can vary between 0 to 100, guys, right? 0, 1, 2, 3, 4. I hope you can understand. All these are the possible values of your binomial random variable x, right? So 0, 1, 2, and up to 100. Let's say all of them have replied. There is a low probability, but there will be probability assigned to this as well. Very low, but there will be probability, right? So now in this particular case, you have these many number of possible values for your random variable x. And this random variable x, we call it as binomial random variable, right? I hope you understood this definition. So here you have three different parameters of this binomial random variable, or you can say binomial distribution. One is number of trials, that is small n. Second is probability of success, that is also fixed and will not change throughout the trials, right? It will remain same. So that is P, probability of success. Now, if I subtract P from 1, you will get probability of failure, right? Because there are only two possible outcomes. When you are flipping the coin, either head or tail. If the probability of coming head is 0.5, probability of coming tail is 1 minus 0.5, that is again 0.5, right? So this sometime we represent in the books, you will find the representation or the notation as Q, right? So probability of success and probability of failure. And the third parameter is number of trials. I hope this is clear, guys. This is the most simplest way anybody can explain, right? And these are a lot of examples I have already given from the real world. You take example of this Tinder. Let's say in a single session on your mobile, you have opened your Tinder app. Now in that, let's say you have swiped 10 right hand side, right? So now what it means is you have liked 10 people. Now out of those 10 people, that is your number of trials, how many of you will get as a life partner, right? So now it can be 0, it can be 1, it can be 2, it can be 10, right? Depends. Or let's say not life partner, you can say this matches, how many matches you will get, right? So now it can be 0, 1, 2, up to 10. Now in this case, every value will have some probability, and your variable x, which says number of matches you will get, that's your binomial random variable, and the distribution of this variable you will call it as binomial distribution. I hope this is clear, guys. Now you just pause this video and try to understand for every example I have cited here. Okay. Now let's move to the calculation of these probabilities, or I can say probability mass function. So if you have any doubt, guys, you can write it in the comment section. I'll be happy to answer that. Okay, now let's move to the calculation part. How do we perform the calculation of individual random variable taking value, right? So mathematically, how will you say the random variable x that equals the number of trials that result in a success, right, is a binomial random variable with parameters p, that is probability of success, that will vary between 0 and 1, right? And n can be 1 to any number, right? So here the probability mass function we calculate using this formula, guys, right? A lot of people will just show you this formula, right? So this is your combinatorial parts. So NCK, if you recall your 10th or 11th standard, there was probability and permutations and combinatorial. So now from that only, this is NCK, right? And this is probability of success and probability of success. 1 minus P is probability of failure. Here N is what? Number of trials. And here K represents probability that our variable will take value K, right? Now let's take a simple example of Tinder swipe, right? Let's say your N is equal to 10. 10 swipe you have done. Out of those, your random variable is number of matches you will get. Right? So that your random variable x, which is nothing but your binomial random variable, right? Because your every trial, every swipe is a Bernoulli trial. Now, if you want to calculate the probability of x or your random variable taking value 3, let's say any value k or 3 you can say, how will be the calculation? Now guys, to understand individual part of this, I'll just build the intuition behind this. So you have first part, that is NCK, right? So this particular part is introduced because your, let's say there are 10 swipes you have done. When you are saying 3 swipes, it can happen on any number or any order, right? So out of these 10, any 3 you have to select. So now to select 3 swipe out of 10 swipe, you have this particular term, that is NCK. Just recall your combinatorial concepts. We use combinatorial to find out k number of selection out of 10 or out of n number of possible outcomes, right? So here we have 10 swipes. You have to identify 3 out of those 10. They can be anywhere. Let's say this one, in this and this. These are the 3 matches you got. Or it may happen that this, this and this. Now, there can be any order of this. That's why we have this term. How many possible way we can extract 3 swipes where we can have the matches, right? I hope this particular part is clear. So this will be represented as, you can write 10C3, which is nothing but, the formula is 10 factorial divided by 10 minus 3, that is 7 factorial, into k factorial, that is 3 factorial. So the formula is n factorial by n minus k factorial and into k factorial. So that's what I have represented in this form. 10 factorial by 7 factorial into 3 factorial. Right? So now this is the first term to identify 3 possible swipes out of 10. Now the next one is the probability. How many, what is the probability of success here? Let's say matches. Let's say that probability is 0.1. That's very high, but let's say it's 0.1. You are smart, right? So it's, let's say 0.1. Now, how many times you got 0.1 or the probability of success? 3 times. So that's what you are multiplying here. Into 7 times, what happened? You got the failure, right? So what is the probability of failure? That is 0.9. That is 1 minus p. And 10 minus 3, that is 7, guys. Right? So this represents the 7 trials where you got the failure. This term represents the probability where you get the success. And this term to extract k possible values out of n. Right? So this is the intuition of this particular formula, guys. I hope you understood. If you did not understand in the first go, guys, you can repeat this video and you can watch it again. Okay, so now this is the formula, guys. You do not have to remember this. I just explained you for just to give you a feel how we create these formulas. Now we have Excel, we have Python, we have different softwares which we can use to calculate this probability. And the functions we are going to use in those softwares in the backend, they will use this formula on. Okay. So that is the idea. You should know when you are using a function or you are writing a code in any programming language, you should know what is the mathematics behind that. This is the mathematics behind that, right? So I'll show you that using Excel, where I will show you how we use this formula. There is a function already which we can use. We do not need to do this mathematics, right? Now, journal, just for your, like if you are learning for your academics, then it may be helpful for you to get the mean and standard deviation of your binomial distribution. So the mean of any binomial distribution or binomial random variable will be n into p. N is the number of trial and p is the probability of success. Standard deviation you calculate using this, the square root of n number of trials into probability of success into probability of failure. Right? So these are the simple mathematics. You can also derive this using the base, which we discussed in our last video. How do we calculate the probability or mean or standard deviation for any probability distribution? You can use that to actually get this result. Okay, you do not have to remember this, but yeah, if required for your academics maybe. Now let's dive into the example, guys. I hope the concept part is clear. Now let's move into the example. First, I'll show you one example, and then at the end, I'll show you one quiz, and there you have to answer in the right comment section, guys. Okay. Let's say it's again practical example, guys. You will be able to relate, and you will be able to use your mathematics, whatever we have learned so far, to answer this particular example. Okay, so let's say there is a marketing company ABC, any name to it, delivers a mail campaign to 10 customers, right? So they are sending mail to 10 customers. Now, the probability of mail opening, the first thing when you are sending a mail, that our customer should open that mail, right? Reply is the second part, or taking action on the mail, that is secondary. First thing is mail should get opened. Now here we are getting, or we are saying, the success is mail opening, right? That is our definition of success in this particular example. How many trials or how many mail we are sending? That is 10, right? N is equal to 10. Success, mail opening, right? That's how we have defined. And the probability of success is 0.1. So here I can say P is equal to 0.1. So what will be Q? That is 0.9, which is nothing but 1 minus 0.1. Now find the probability of exact 2 customers opening the mail. The question is probability of X is equal to 2. This is what you have to answer, guys. Now if you are using calculator, you can use 10C2 into probability of success. How many times we got the success? 2. Probability of failure. And how many times we got the failure? 8, right? So this is the formula you have to do, and just use calculator to calculate this, guys. Even I can simplify this. 10 factorial divided by 10 minus 2, that is 8 factorial into 2 factorial, right? And this is the formula for this, right? So it will be 8. Now we can actually use binomial distribution function in Excel, guys. Okay, to calculate this. I'll come to that part, guys. Okay. Now let's look at the second example before going into the Excel, guys. Both of these I will solve using Excel as well. Now find the probability that at most one customer will look at the mail. Here important part is this, at most one customer. So what we are looking from this is, if you translate into mathematical form, probability of getting at most one customer look at the mail. That is 1. Right? So probability of X less than equal to 1 at most. If I would have used at least a term, then it would have been this, greater than equal to 1. But here I have used at most, so that's why less than equal to 1. And if you recall your last video, guys, this definition reminds me of one function. And what's that function, guys? That is CDF, cumulative density function. This one is PMF, right? So in the first example, you are calculating PMF. In the second question, you are actually using CDF, cumulative density function. So here, cumulative density function, probability of X less than equal to 1. You can write this using simple form, probability of X is equal to 0 plus probability of X is equal to 1. Right? So this is actually 1. Right? So these are the two probability you have to sum to get your answer. Now again for this, we have function in Excel, guys. Let's move to the Excel and solve these two problems. I have my Excel open. Now let's see what are the different informations already given in the example, guys. So we have number of trials. How many number of trials? 10, right? Then second information is about probability of success, right? That is already given as 0.1. What will be the probability of failure? That we have already seen. Probability of failure, that is 1 minus probability of success, that is 1 minus 0.1, 0.9. right? Now let's look at the function which we use to calculate probability mass function as well as cumulative density function for binomial distribution, guys, right? So in Excel, we have different formulas. If you go to the formulas tab, we have statistical functions. Go to more functions, and now here, come to the statistical part, right? You will find a lot of functions over here for different distributions as well as different statistical concepts. Right now we are learning about binomial. So we have functions for binomial distribution like binomial dist and binomial in. So the function which we are looking is binom.dist, right? We'll come to this. So our binom, let's import this function or use this function binom.dist. There are 4 inputs you have to provide for this particular function, right? So first is number of success, that your random variable taking your value. So in our first example, if you recall, our first example or first question was exact 2 number of customers will reply to that mail or open that mail, right? So now 2 comma, how many trials total? 10. Then what is the probability of success? That is 0.1. Or I can use these cells, guys, as well. So now let's say rather than number of trials manually feeding, we can use this cell info B4, right? Probability of success, it's here in B5. Now in the last argument, you specify whether you are calculating PMF or you are calculating CDF. So here if I write true, it means you are calculating cumulative density function. It's already giving you a hint, right? It's telling you whether you have to use true or false. Please specify that. So true is for CDF, cumulative distribution function, right? Or false, probability mass function, right? So now you have true here or false. So let's say in our first example, it was asked what is the probability of x is equal to 2. So here we are calculating probability mass function. So that's why I have used false. So now if I enter, we will get the value. The value is coming as 0.19371. That's the probability that out of 10 trials or 10 customers, only 2 will open the mail, right? Let's calculate this for another example where we are calculating the probability of exact one customer opening the mail. So let's say that is binom.dist. So here 1, number of trials, I'm specifying number of probability of success, and then again what I'm doing, I'm calculating PMF. So that is 0.38. Now let's calculate this for 0 customer as well, that no customer will open the mail. There will be probability to this as well. Now let's calculate what's that, right? Again false, right? So that is 0.348678, right? So this is how you calculate the probability mass function for binomial distribution. Now let's look at the function for the probability or cumulative distribution function, right? You can say it cumulative density or cumulative distribution function. Idea will remains the same. So here what you need to find out, x less than equal to 1, right? So one option is you can sum these 2 values, because this represent probability of x taking value as 1. This represent probability of x taking value as 0. That's why I calculated, so that you can manually do this calculation, right? So the number is, or the probability of x less than equal to 1 is 0.736. Now let's try to find out the same value using our CDF function. So for this, everything will remain the same except the last argument. So here what we have, we are calculating the number of success as 1. Then we have the number of trials, and we have probability of success, and we have to specify true for CDF, right? Now you can see both of these 2 values are same. It means our formula is also correct, and we have validated it. That's how we can use binomial distribution function to calculate PMF and CDF in Excel, guys. I hope this is clear. Now you know how do we calculate PMF and CDF using calculator. I have given those formulas, as well as in the Excel when you are running this function, that formula is also is actually getting calculated in the backend of your Excel. So I have a question for you as well, guys. Now the answer you have to write it in the comment section, as always we are doing. So now here what we have, it's again a practical question, guys. Suppose there are 12 multiple choice questions in any quiz, right? Each question has 5 possible answers and only one of them is correct, right? So single option is the correct one out of 12 multiple choice questions. In every multiple choice questions, you have only one answer that is correct. Now, what you need to do, you have to actually calculate for the first part, what is the probability of having 4 correct answers if a student attempts to answer randomly, right? So for the first part, you have to calculate what is the probability of X, that is correct answers. Success over here, we call it as, we are defining as the correct answer, and X is equal to 4. Now, in the second part, you look at the question, find the probability of having 4 or less correct answers. And here we are calculating less than equal to 4. So now I just need the answer of these two. You have calculator, you have Excel, guys. Any of those tools you use, and just give me the answer in the comment section, guys. And based on this, I get motivated, guys, that you are learning from these videos. So I'll be waiting for the answers in the comment section, guys, right? And if you are liking the content, this content takes a lot of time to get created, guys. I'm repeating it. It takes a lot of time. So if I am putting efforts, I need some motivation from your side as well. So like the video, share with your friends, get more reach for these kind of content, guys, because you will not find this kind of content in other YouTube videos related to binomial distribution, guys, right? So I hope this concept is clear. If you have still any doubt, you can write it in the comment section. I'll be happy to answer in my upcoming videos or in the comment section itself, right? So thanks for watching till the end. Let's meet tomorrow, guys, with new distribution from our discrete probability distribution category, guys, that is geometric distribution. So that's what we are going to learn in our next video. By that time, take care and keep learning. Thank you.